Yeah, so people can join in. I'll keep the couple of, initial 5 minutes introductory. So we'll give chance to people to join in, and then, yeah,
Yes, yes, sure.
sure. Okay, let me put it in full screen. Is this good, or you are able to see the, are you able to see my slide correctly?
Yes.
Okay, all right. So today's session will be around Azure Machine Learning Studio for cloud professionals, wherein we will touch upon how to use and find your way around Azure Machine Learning Studio, what it comprises of, what are some of its features, how out of the box, certain things which it allows you to do apart from building your custom code, and we'll see some visual metrics it displays on the portal, and some functionalities like how to uh, build experiments and child runs and track various versions of models and so on and so forth. All right. So we will keep the introduction very brief, like, as to machine learning and AI in general. We'll keep that bit a little short, and then we will look at features of Machine Learning Studio itself. Um, we will probably, if time permits, we will do an auto ML experiment. We will see about the designer and some of the out of the box wonderful features which are provisioned by the Machine Learning Studio. So let's begin our journey. Quick brief about me. So currently I lead the AI IoT offering business leadership at Avanade, and I'm Microsoft MVP for AI. And yep, so if you want to connect with me, you can always do so on my Twitter handle, which is at fuzzymind1. So this is the agenda today. We'll have a brief introduction to AI, then we'll look at machine learning. If time permits, I will also show you a brief, how computer vision experiments and NLP and conversational AI experiments are done in Azure Machine Learning Studio. Okay. So we'll learn the following concepts, right? We'll learn about Azure machine learning itself, and we'll learn about, we'll have a quick footnote about responsible AI, because we are talking a lot about auto ML and low code, no code ML, right? Which comes with its own set of challenges. So that's why we will have a quick overview of responsible AI. So when we talk of artificial intelligence in Azure, right, I would not, want to reiterate about what is AI, because frankly, at this step, this is a moot point discussing about what is AI. So it's just that, imparting human level intelligence to machines, and being enabling machines to imitate human tasks like what we do, right? Speak, so natural language processing; see, which is computer custom vision; be able to make decision, right? And have conversational, engaging conversations, dialogue flows, which is your conversational AI bot framework, intelligent assistants, and all that good stuff. So the common AI workloads which are available natively in Azure Machine Learning also, they follow these 5 paradigms, right? So you have machine learning, wherein you will build predictive models, or you will build your classification linear regression models, right? Basis of your data. So this could be either your supervised or unsupervised machine learning. So that is one workload. The second one is anomaly detection, where normally you will try to spot anomalous behavior, some sort of unusual patterns in a data series. Third will be computer vision, which is object detection, image processing, segmentation, face recognition, and all of those good stuff related to computer and custom vision. Fourth will be NLP, wherein you are trying to comprehend the text. So what is written, a Q&A, BERT, OpenAI, GPT, all of those word embedding, semantic analysis, text analytics, keyword key phrase extraction. These will come as a part and parcel of your NLP. And conversational AI. So in conversational AI, it is your bot frameworks, right? Wherein you will have agents, intelligent virtual agents being in conversation with you to make you reach your end result. Okay. So in if those 5 pillars, if we try to visualize them in Microsoft Azure, right? These are the 3 different offerings which you get. So Azure Machine Learning enables you to do all of the ones which we saw in the previous slide. So you can build custom models, you can build auto ML models, you can build low code, no code models, and um, then you have, sorry, excuse me. So Azure Machine Learning is a platform itself to train, deploy, and productionalize your machine learning workloads. Okay, cognitive services is out of the box AI services which you can consume and make your applications intelligent. So basically, text analytics where we say extracting keywords, key phrases, or your PII entities, right? Personally identifiable entities, or being able to recognize names of celebrities, landmarks, those kind of things. So face recognition, object detection. So all of these are speech to text, text translation. So these are cognitive services which are out of the box. So you need not code or write a model right from scratch in Python or any other language of choice, or you don't have to do all of those tedious stuff. These services are available out of the box. You can directly, use them as APIs in your code. Okay, and finally you have the Azure Bot Service, an entire bot framework where you will be able to write programs for having conversations. So you have a lot of components there, like conversation cards are there, right? Adapters are there. And you have, like, conversation starters, conversation flow indicators. So that will be provided by bot service. Okay, so these are the three different pillars on which the Azure machine learning itself rests. And today we will be covering the first part of that, which is the Azure Machine Learning Studio, the platform which enables us to manage, build, and manage the entire machine lifecycle. Machine learning model life cycle, right from training to evaluating, inferencing, maintaining, and finally also detecting data drift, if we want to do that. Okay, so before we move on to your Azure Machine Learning Studio itself, a very brief note about responsible AI. Why I want to touch upon on responsible AI before we move on to the Machine Learning Studio is because when you're going to use the Machine Learning Studio, a lot of us will experiment or will normally, tend to gravitate towards using the Auto ML or the Machine Learning Designer, which is, out of the box machine learning. So let's say I want to do a linear regression where I'm, basis some past data, I want to forecast a futuristic value or futuristic trend, or I want to do a time series forecasting where I'll give you the data. I will give you the value which I want to predict based on my data. I will also give you the features, which I want to be used to predict my final outcome. Okay, and then the platform itself, the machine learning platform itself, is responsible for then choosing, shortlisting the algorithms. Now, why responsible AI is because I should be made known that these algorithms were chosen, and the accuracy, whatever the final outcome is, because of some series of steps which the model took. Imagine that as a programmer, when I'm writing something, I know what I'm doing, right? I mean, if I'm writing a loop, if I'm multi-threading, if I'm parallel processing, I am accountable for my reactions. So the code or the output which is produced, I already know that the output is because of what steps which I took. So much the same, the automated ML should also be white boxed or transparent. It should not be a black box AI, like I give an input and you just get an output, and in the middle what goes on you don't know, whether your what algorithm was used, what hyperparameters were used, what all algorithms were considered as candidates before I zeroed down on one particular subset, right? So all those decisions should be made known to me so that I know the reasoning, like just transparent to me. So I know the accountability, I know the ownership of the final decision. So the principles of responsible AI, especially when it comes to low code, no code models, is fairness, reliability, and safety. Privacy and security, which is my data is not going out anywhere or it's not leaked anywhere. Inclusiveness, because the data set which I'm feeding to my algorithm should be diverse. It should be representing all demographics equally. transparency, like, it should be, I should be known, like the output was due to what, and accountability. Because if the algorithm is transparent, the platform is transparent, I should also then be able to hold it accountable, right? So which means, imagine that you are coding a driverless car program, and unfortunately there was a mishap, an accident or something like that, then you should be able to know the accountable person or the accountable system for that, right? Which are, these are the 6 tenets of responsible AI. And I mentioned these because as we will be seeing auto ML, no, low code, no code ML, then these principles become very important. Now let's dive into our journey of machine learning. Okay, so we will learn about these basics of machine learning, and then we will dive headlong into the Azure Machine Learning Studio. All right. So yep, get ready. Now, when we talk of machine learning, right, even on the Azure Machine Learning portal, when I'll show you when we are building our automated machine learning models. So what does machine learning do? It is just creating predictive models by finding relationships in the data. That relationship can be linear relationship, it could be a time series relationship, it could be a binary classification relationship, or you might have to find a relationship by clustering like a sized or related similar data together. So it is just trying to understand your data and building some predictive trends around that data. Okay, right? So this is like, if you had some diverse data after machine learning, as a human, if you see that, if you see some images or some objects, you'll tend to cluster them together. Much the same, machine learning also does that, right? Given a set of data, you're teaching the machine to identify certain trends in that, and then group the data or predict the data accordingly. So the basic algorithms which we see in machine learning are regression. Regression meaning you have past data and you are going to predict the future data based on the past trends. So here, for example, if I'm trying to have a past historical data for temperature versus the bike rentals, right? So on a given day, if the temperature was 56 degree Fahrenheit, then the bike rentals were 115, and other parameters like what was the humidity that day, whether it was a weekday or a weekend or a public holiday, and so on and so forth. So these are called the features, right? So these are called features of the data, and this is the output which I want to predict. Okay, so given the temperature and humidity, these are the bike rentals, and I have data for a certain period of time, and based on this data, I have my machine has to identify a trend and then predict for the future, like, so given this data, it has to try and find a relation between this x and the y, the output value which we call as the label, the predicted value. It has to find a relationship between that, and then it should be able to apply that sort of equation which it finds to some futuristic. So like given this past trend, find the relation in this trend, and then using that equation or using that relation or that function for a futuristic value of humidity, you try and predict the bike rentals. So this will be a sort of linear regression. Okay, this is the most common machine learning problem we come across in the data science journey. Okay, so this is your characteristics features X, and this is your predicted value Y. And typically you're going to distribute your data as training and validation. Normally it's an 80-20 split, right? So whatever data you have, you split it as 80% training, and the rest 20% you will use it for scoring your model. Okay, in the linear regression, basically what you're trying to do is you're trying to fit a line, okay, a line between your two variables like x and y. So temperature, humidity versus the cycle rentals. You're trying to fit a line through that, and then you're trying to derive an equation. So this part is called as the intercept, right? So the part where the line cuts the y-axis is called as the intercept. Okay, and this is the slope of the line. So normally you're trying to have a relationship between x and y as y is equal to mx plus b. M is the slope of the line, and this b is the intercept where the line cuts the y-axis, right? So something like this. You'll try to come up with an equation mx plus y, right? Mx plus b, sorry, mx plus b. Okay. And then using that equation, you will try to predict the values in the for the validation, the scoring data, which we call as. Okay. So using this equation, you predicted for the values of validation. So for the values of temperature in the validation, this is the value of the bike rentals. And I'm calling it y dash, okay, because that is the predicted value, not the actual. And whatever difference you get between your predicted and actual is called as the error, right? So this is called as the error. So as you can see, right, this is actual versus predicted. This is called as the error, and the accuracy of your model, the equation which we got, right, mx plus b, that itself is decided by how much margin of error you have. Okay. So for example, here our model is doing fairly well, right? Like predicted versus actuals is not a huge variation, and that's why we can fairly assume that our model accuracy is good enough. But then depending on, so that's why when you finally train and build your model, you have a lot of accuracy metrics to sort of measure your model performance. Like there are in linear regression, you have root mean square error and f2 score and sorry, r2 score and f1 score, all of those good stuff, right? So like regression will be an example of supervised machine learning. Why supervised? Because as you can see, I have some data. I'm using that data, historical data, to establish an equation. And then whenever, I see that there are a lot of variations in the output, the predicted output. Okay. I'm trying to jump in and correct by means of even having more training, or by means of hyperparameter tuning, using optimizers, okay, using scalars. So all of with the help of all of those things, I'm trying to get to as close and accurate model as possible, which is, I am as a human, this is a human in loop, right? So whenever I'm trying to correct the predictions based on certain expected trends, right? And this is why it is a supervised learning. So I'm, as a human, I'm supervising, and I'm retraining it to make it more accurate. Okay. Classification is where, I would want to sort of distribute my data into different classes. So we have binary classification and multi-class classification. Binary is where, it is a yes no sort of a thing, like either it falls in one bucket or another bucket. So a classic example you will find on Azure machine learning portals or your tutorials is where you have a series of medical parameters like your heart rate and insulin and all of those things, and basis that you have to predict the values of whether the person is diabetic or non-diabetic. So like it's a binary, 0 or 1. 0 meaning non-diabetic, 1 meaning diabetic. Okay. And this is your example of classification. This is again supervised learning, because I have data, I have the values, okay, 0 and 1, and based on these further trends of data, I want to predict like for parameters which are heart rate and blood pressure and other things, what could be the probability that that patient could be diabetic or non-diabetic. Okay. So classification is also an example of supervised learning. Again, like regression, we are also dividing that into training and validation. And then you will be trying to, this will be like now this will be a curve fitting. You're not trying to fit a line, but rather a curve. And this is called as the threshold. Okay. So you need to decide above what threshold is your probability going to be 0 or 1. So if I set a threshold of 0.6, I will say that everything above 0.6 probability, more than 0.6 is non-diabetic, and everything below that will be diabetic. All right. So this is called as the threshold. And depending on your use case, your threshold values, or there are other algorithms also which will allow you to set your thresholds as well. Okay. So this is yeah, so as you can see, right? And then you will be calculating probabilities, right? So probabilities of how much that patient, the probability with which that patient is either diabetic or non-diabetic, right? So here, as you can see, this is a calculated value and this is the actual value. Now you will see that for in the four cases which we have here, two are predicted correctly and the other two are predicted wrongly, right? So here with these parameters, actual output was patient is Yes, it's non-diabetic. Here also non-diabetic. For the second observation also actual and predicted match. But then in the next two instances, the actual and the predicted are just flipped opposite, right? So which means our model is not accurate. Like it's only working with a 50% accuracy because out of your four observations, only two are classified correctly. For which means, for our binary classification, we have something called as a confusion matrix where you have predicted and actual values tabulated. And then you have something called as false positive, false negative, true positive, true negative, right? And that will enable you, depending on your use cases, that will enable you to sort of decide the accuracy of your model. And you have other metrics called as average precision, average recall, MAP, mean average precision, which will able to sort of help you to decide on the accuracy of your model. Okay. In clustering, it is sort of, it's unsupervised machine learning because it's like, I give the machine a set of data, right? And then I don't know whether there are any hidden trends in the data or the data is trying to tell me a story or some of those things, right? So it is the machine who tries to bring in semantically similar or whatever, like, otherwise similar data together and tries to tell me that there are patterns in my data and tries to classify that data, cluster the similar data accordingly. And which is, it's unsupervised because as a human, I'm just feeding the machine data, take this data and now sort of, try to find if there are any groups here. So it is the machine who tells me, who comes out with the number of groups, 3 or 4 or whatever is the optimal number, and tries to group my data. Okay. So in clustering, typically it's like, you are trying to establish a centroid, okay, and then try to then, calculate distances between have new centroids, and then points which are near to the new centroids are clustered together. And as and when you start going iterating, you will find that similar data points are grouped together, and if you try to cluster them further, it might drop the accuracy of your model. So there is a method called as WACC, which will enable you to tell the cutoff point of your threshold of cluster. So how many clusters are optimum enough, right? Elbow method, it is called as the elbow method. So after that optimal point, the actually accuracy of your model declines, right? So clustering mechanism is unsupervised machine learning. Okay, so having had these basics now, let us jump into the Azure Machine Learning Studio itself, and let us see what all some of the good features which are afforded to us there. Okay, so Azure Machine Learning is a platform. You need an Azure subscription for that, right? Or portal.azure.com, and then you need to create a machine learning workspace inside of that. And once you create a machine learning workspace, you have compute, right? So something on the portal itself, when you are going and creating your notebooks, you have to have some computation behind that, which is going to run your workload, something which is going to run your notebooks or your code. So which is why you need to create compute. Of course, you will have to create data, and you will have to create models. Okay, all of these are organized together in experiments. Okay, so I can have one experiment for linear regression and another experiment for clustering, another experiment for classifications, where I can have multiple runs of my model. Okay, so we'll discuss all of these things, but these are the basics. Okay, and finally you will have services. So your model you will be deploying as a service, as a REST API or as Azure Kubernetes service, AKS. Okay, so, okay, so let us go to the portal first, all right, and let us look at some of the features which are there. So again, AML, automated ML, is also auto ML, which we call as normally. Auto ML is also a feature which is afforded to us in Azure Machine Learning Studio. And auto ML, as I said, right, it takes out most of the hard work. So the brain, the model itself is generated, the code for the model itself is generated out of the box in the machine learning studio. You just need to feed the data and indicate what type of problem are you solving. So is it a regression problem, or is it a clustering classification problem, and what are the, some of the accuracy metrics you want to have, give the data to it, and then it will just give you the model. You need not write any codes or import any libraries, nor worry about fine tuning or hyperparameters, optimizers. Okay. And you have two things there. You will have an AML and also a designer. Imagine it as sort of a SSIS workflow which we had, right? So where you could drag in the source and destination and then have the data transforms in between. So similarly, you can also have a drag and drop workflow sort of a thing, which is called as the Azure Machine Learning Designer, where you can design and experiment in flows, and which we call normally as a pipeline. So you have a training pipeline, you will have an evaluation pipeline, you will have inferencing pipeline. Okay. So both of these you will be able to finally, create services or and models which you will be able to deploy and consume in your end applications. Okay. So these are some of these good things we are going to see now. So let us have a look at the Azure Machine Learning Studio itself. All right. So this is my this is my subscription, my Azure subscription, portal.azure.com. Okay, what I'm going to do here now is I'll go and first of all, before we go to the machine learning studio itself, I need to create a machine learning workspace. Okay, so I need to create a machine learning resource itself. If you go to the portal and you click on create a resource, you can see here, right? So you can just type machine, and yeah, see, first you should create a machine learning workspace. Okay, so once your workspace is created, so just create and give the name, okay, a region in which you want it to be created and stuff like that. So this is your machine learning you would want to create first. So I created my machine learning workspace, which is called knowledge mining ML, right? You can give any name. And once that workspace itself is created, okay, then you will have a button here called as Launch Studio. Okay, so I'm going to click on this Launch Studio. When you click on the Launch Studio, it is there when you are navigated to the Azure Machine Learning Studio. So first, from the portal, Azure portal, you need to create a machine learning workspace. Then you navigate to your machine learning workspace. You click on the Launch Studio and you will be shown the Azure Machine Learning Studio. So before we move on to actually creating auto ML and stuff, let us have a look at the left hand side. Okay, so first in the home page you will see notebooks. Okay, if I go to notebooks, this is where you will be having your Python notebooks. Okay, not Python notebooks, a way to code your Python notebooks. Okay, so as you can see here, if I go navigate, yeah, I have various experiments here for object detection, and then this is a time series. Okay, these are my Python notebooks. So if I were just to sort of expand them, you can see that I have Python codes here, pipeline, and I have all my data. So these are nothing but your traditional Python notebooks. Okay, so you can code your Python notebooks. You have automated ML and designer, which we will see via an example. You have something called as data sets. Data sets are nothing but the data on which you operate. Okay, so when for example, if I want to have a regression model, then what is the data for my regression case study? What is the data for my clustering classification? So these are data sets which are going to be utilized in your designer and your automated ML. Experiments. What are experiments? Experiments are a grouping, okay, of your entire, what you can say, like your entire machine learning journey. So for example, if I'm creating an automated machine learning project, okay, then that project itself, whatever model or whatever steps I am going to have for that particular problem, I can put it in an experiment. So as you can see here, I have a lot of experiments created here. Okay, and each experiment, so if I just go to the duck detection experiment here, each experiment can have multiple runs. Okay, so these are the multiple tries for my model. So as you can see, it has a status failed, failed. Some of them are completed, some of them are cancelled, right? So experiments is a grouping of all my data and data sets and all my pipeline steps. Okay, and then I can rerun experiments and they will create different runs of my experiment. So these are the various different runs, and you can also see some characteristics here. Okay, and then you can also have visualizations there. if I wanted to, for example, as a data scientist, I wanted to share some of my experiment runs and tell you that, the last 3 runs succeeded and what were the metrics for that. So I can also add charts. So we'll see that, no, it's not, I mean, this is not possible in this particular experiment, but I can show you how to add charts and how to edit the columns and screenshot it and send it across for as a report or something like that. Okay. Then you have pipelines. So pipelines are nothing but, machine learning pipelines where, you will have all your steps like data, your data gathering and your training and scoring, evaluation as workflow steps, which you can reutilize again and again. So we'll see also pipelines a bit in visual format because as I speak and explain, it may not be very apparent to you, but we'll see the pipelines with the help of an example and how you will be able to uh, leverage on pipelines. Okay. And finally, environments. So environments is your different environments for your models, like production environments could be different, deploy. So the environments are more used for CI/CD DevOps purposes. Models are your models themselves, right? The ones which you're creating. Okay, so I have created like the models, various models which I have created. So I have created for object detection YOLO model. I have trained that model in my notebook. So these are the models which we have trained. Okay, and you are given like it is created by the person and stuff like that. Endpoints are the deployment endpoints on which I have deployed my model. Okay, so the trained model, finally I have to deploy it as an AKS or an ACI, Kubernetes service or a container instance, where I can then consume it in my application, right? So these are the endpoints on which I have deployed my models, right? And finally, you have here you have something called as compute. Okay, so compute is nothing but when we are running experiments or when we are running automated ML or designer, you will be needing some sort of a computational platform. So because this is platform, right? Azure Machine Learning Studio is platform as a service. So you will be needing some computational power to run your notebooks, to run your experiments, which is afforded by the compute instance, compute clusters, inference clusters, and attached computes. Compute instance are basically used for your normal small workloads, right? I mean, if you don't want to worry about memory footprint or GPU, CPU, then compute instance is out of the box. I mean, what sort of so you just click on new here. If I were to show you compute instance, give the name, what is the location, which machine type, GPU or CPU, depending on your simple experiment CPU. But if I have deep learning or a lot of image related stuff, then I might go for GPU. And then you can select from the recommended options, right? Compute clusters are more when you want to have parallel computation. So if the compute clusters, you will be able to see that you will want to dedicate a virtual machine tier which is dedicated or low priority. Then you have to select from machine size, and you will also be asked to select the nodes. Okay, so if I here you'll be have to asked to select the nodes, number of nodes, right? So from 0 to whatever that is, and the idle seconds before you want it to be scaled down, and whether you want to have a SSS access, and you want to assign a managed identity and all of those things. Okay, so when you want more computational power, complex computational things and parallel processing probably, then you will go for compute clusters. Okay, inference clusters are used when you're trying to do your inferencing on your complex models. Okay, attached computes is if you already have you have some computes probably there already as Azure Kubernetes or Docker, and you can attach it here as well. Okay, or if you have your own HD Insight cluster, your own Databricks cluster you've already created, and you don't want to create it again in compute clusters and stuff, then those things things you can bring in as external compute. So if you have computational workloads available already elsewhere, which are already supported by Azure Machine Learning, like Databricks, HD Insights, another VM, a deep learning VM or stuff somewhere, then you can also bring it and attach it here. Okay, so these are external computes created which you can import. These are instances which are like, low weight and not low weight, lightweight and easy to use. These are for a bit complex calculations and for parallel computing. And inference clusters are for inference workloads where you want to infer something like, once your model is there, now you want to build an inference pipeline for that. So you will have inference clusters. And finally, these are the external computes. Okay. Linked services again, okay, so if you go here, linked services connect to other Azure services like Synapse Workspace. Okay, so I have a Synapse notebook, for example, or a Synapse analytic machine learning workload, which is running Wapal, Wabbit, or another MML Spark stuff. Then those I can import it here. Okay, and data labeling are the labeling tools for your data sets, right? So labeling labeling tools, meaning if you want to label images, right? So for example, if I want to have an image classification project and I want to teach the machine that this particular image is pasta and this particular image is pizza, that sort of a thing. So these are called labeling tools. So these are the labeling characteristics before I train my model. So I hope the gist is clear. What are we trying to do? Okay. So now let us try to look at automated ML, right? So in automated ML, I've already created compute. Okay. So I've created a compute cluster here. I have created two clusters, right? And as you can see right here, those things are already created, and current node count is 0 because it is not, it is not being utilized. It's an idle state, right? So it's running, but it's not being utilized anywhere. So let us utilize this compute cluster for some of our experiments here. Okay, so let us go to automated ML. And while I'm, discussing this automated ML experiments and stuff, please, if you have any doubt or if you want to comment or you have any observation, anything which is related to what we are
Hello.
discussing. Yes.
Yeah, hi, ma'am. Hi, Priyanka. Thank you for your on that session part. Yeah, I could see that the Azure has their own ARM templates and to set up your
Sorry.
own.
Yeah.
Hello, able to hear
Yes,
me?
yes, yes, yes,
Yeah,
I'm able to
Azure
hear
has
you.
their own ARM template build up and they have their own pipeline CIC core. So, what is the best practice can develop? Because I can't do the as a ML ops engineer or ML engineer can directly go or Azure Cloud engineer to directly do from the console side. If you want to do automate the process as a CI/CD basis or to do train the pipeline or to to find out the next any drift happens or any variations happen over the experiment. So, what's the best practice who can help us on that? Yeah.
Okay, so this is more, you are asking with related to CI/CD or with related to the data drift.
Yeah, yeah, exactly.
No, I'm asking you. Is your
Yeah,
question
yeah,
more for
yeah, 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 yeah,
CI/CD or data drift?
yeah, yeah, both. Because I want to retrain the pipeline so that I need to have the automated pipeline where
Yeah.
it has to check those drift and find out that exact cost and to take up the new data set and flush into that and you have to retrain the people. So what
Correct.
is the
Okay.
best practice I
Yeah.
can? Yeah.
Okay. So I'll be coming to that, right? For your for detecting data drift itself in Azure Machine Learning, you have something called as HyperDrive experiments. Okay. I'm going to type it out in our chat window. Okay.
Okay.
So hyperdrive experiment. So it is, first of all, when you're talking of hyperdrive experiments, it is twofold. So sorry, when you're using when you're trying to detect data drift also, it is quite possible because every day you will be, you will have a sort of your training cycle where you are going to evaluate your model accuracy, okay, based on the whatever the data set, right? So we will also, if time permits, I'll show an experiment. Okay, so
Sure,
the
sure.
question which are asking, right? We have already faced a situation where we have an object detection model for retail, where routinely objects are being, it's real time. Okay, so objects on the shelves. So imagine that you have a you have what is that? You have a store, okay, a retail store, and you have cameras installed on some of the shelves, and routinely those cameras are detecting new objects added or removed or stuff like that. So how does it know that pasta is now below the inventory? So if I want to maintain an inventory of 50 packets and now it is only 43 packets, how does it know that it has fallen below the inventory? Is obviously only when it knows what packet is tagged as a pasta, right? And then eventually what happens is, if let's say it was trained on 10 varieties of pasta, and over a period of time the pasta varieties increase, and now it's like, it is a wheat based pasta, or it is a brown muesli pasta and stuff like that, then my model accuracy declines, right? I mean, I'm not able to tag those newly added varieties of pasta. I'm not able to recognize them as pasta, so the model accuracy declines. In that case, where you want to be able to have set up for, I mean, look for data drift, then you have to build a pipeline where fortnightly, or depending on the criticality of your tasks, fortnightly or daily or monthly, you are sort of, checking your model accuracy. And then if your model accuracy falls below a threshold, then you know that yes, it is time for me to again retrain my model. And that retraining itself, it could be all automated, or you can have a human in loop, like, the human will redirect what data set to be used, or which extra data to be added for the retraining, and then again redeployed. So all this process, the CI/CD process itself, from an MLOps perspective, can be all automated using machine learning Azure ML pipelines, okay, or Azure ML pipelines and CI/CD with Azure DevOps. Those that is possible, and you can make it halfway human in loop or totally automated. So as soon as your accuracy falls below a certain threshold, you will be notified via email saying, like, hey, do you want to retrain? And if you just click on retrain, then it will be recorded, like a button click or something, and you will be able to train the entire model again with new data, okay, and then new accuracies are computed. So currently we have done this sort of thing on IoT hub. So it's IoT edge, Azure IoT edge machine learning, where we are, if the edge model accuracy falls behind a certain threshold, then we are training it again on cloud and then redeploying the model on edge. Now, this we have done with not only with Azure Machine Learning Studio standalone. We have used we have done that using Databricks as well. So Databricks plus Azure DevOps and plus Azure Machine Learning pipelines. All of these things, three things together in tandem, we have built this sort of MLOps pipeline. So does that answer your question?
Yeah, Priyanka. Yeah, I have a question in the end. I'll ask, but let's complete your demo. Yeah, thank you.
Okay, sure.
Thank you.
Okay. Okay. So where was I? Yeah. I was in the automated ML, right? So yeah, for the automated ML, let us see like how easy it is to use and what all functionalities it gives us. So now I am on automated ML. I click here. I'm creating a new automated ML run, right? Then first of all, it will ask you for your data set, on which data set you want your machine learning auto ML run to be created, right? So either, I mean, I have a series of data sources if you have any, otherwise you can create your own data set, right? So you have, like, you can create from local files, from data store, from open data sets, like, if I have some image models to be trained, then I can use open data sets like RetinaNet, ResNet, and all of those good stuff available out there, or from web files. So if I have files available somewhere on file stores or GitHub, then from web files I can do that. Or if I have my local files as well, right? Local Excel files or local CSV files, right? So I'm trying to do from local files, right? So let's say I'll give some data set name, give some name to that. So as we looked in the slide, I mean slide deck, right? We are going to do for the bike rental. So if I give a some name bike rental to it, and data set description, you give some description to that. You click next, then you indicate that the what is that? Yeah, it's a tabular data set. And then I'm going to browse the files, include them, right? So excuse me. Why it's not showing me here? Yeah, okay. So let us do that. I'm opening the bike files, right? And then if you want to say skip data validation or stuff like that, right? It is a tabular data source. And once I click on next, it will be parsing the data set info, right? So it's a comma delimited file. You can specify the delimiter, whether it's a comma or a pipe or whatever that is, UTF encoding. And only the first file has headers, because in my file only the first row has headers, right? So then it will pass the data. So this is my data which I have. Okay, so these are all the features of the data set, and this is the final rental which I have to predict. Okay, right? And if my data set contains multi-line data, meaning my data is spilling over multiple lines, it's not only a single line data, so I can include that if that is the case. But that's not the case for our data set, so I just click next, and then it will tell you what columns from your data set you want to include, right? So I'm including all the columns here. You click next, and then it will ask you to create the just confirm the details, and I said create. Yes, so this is the data set which I'll be using for my automated machine learn run. Okay, and now I'll just refresh this. Okay, so whatever I created now, it's already been there. Okay, right? So I'll select the data set whichever I want to use. So the one which I recently created, or the one which I had created for my previous experiment, right? So I can select, right, the data set. I click next. Now it will ask me uh, to select an experiment name. Like, do I want to select a experiment name, or I want to create new? So I'll say I want to create a new experiment. I don't want to use any existing experiments. Okay. So let's say this, I will say as bike regression auto ML. This is the experiment which I created. Target column is the column which I want to predict. I want to predict the rentals, and cluster, compute cluster. I'm going to select a compute cluster. So I am selecting one of the clusters which I've already created. Okay. And I click next, then it is asking me what is the task, what is the problem which I'm trying to solve. So I'm trying to solve a regression problem, right? Given the past data, I'm trying to predict something. So regression, and then you use the button additional configuration settings. So what is the precision, the primary metric which I want? So the primary metric which I want is normalized root mean square error. I am ticking the boxes explain best model, because whatever model it has finally, built, it should be able to explain that to me, which is a part of the responsible AI which we discussed. And then do I want to use all the supported models which are given here, like gradient boosting, elastic net, blah blah blah? No, I don't want. So I just want to use random forest and sorry, I want to use XGBoost and light GBM. Okay, so I want to use just random forest, XG boost and light GBM for my particular experiment, this auto ML. What is the exit criterion? Exit criterion is because we have only small set of data. Once just stop after 30 minutes, zero point 0.5. Okay, and metric threshold I'm setting it as 0.85. So which means at around 85% accuracy, you can, once your model reaches 85% accuracy, you can stop training it. 85% accuracy is good enough for me. Okay, so that is my score threshold, right? I'm going to save this, and I have done all the settings. So regression, featureization settings is, what are the which feature selection, like, for example, for my model, which are the features, or which are the facets of my data that probably affect the accuracy the most, or the rentals which I want to predict, right, are based on which, are heavily influenced by which of these features, right? So I have enabled auto featureization here. Okay, and then I just click next. So validation type, keep the default values, And once I click finish, what it is trying to do is I have indicated everything which I want, right? I've indicated my data set, I've indicated the type of problem I want to solve, I've indicated the accuracy threshold metrics like I want to I have also indicated the accuracy type. I want a normalized root mean square error and all of the basic configuration for a regression model, and I have just clicked on submit or start, right? And see, it has started my run, it has created my experiment. Okay, and these experiment run names, right? So experiment name I give it, but these runs are created on the fly, right? These run names you can also edit it. Okay, but then I enjoy all the automated names it comes out with. So good parsnip, it has given the name for the run and it is currently in progress. Once the status is completed, we will be able to see the status. All right, so let's go to experiments. Okay, and then let us refresh it, and you will be able to see all the experiments which I have created, right? So this is the current one which we created, and this is, I don't want to view archived experiments. Okay, yeah, and then this was the run which I created previously for the pre-bike auto ML. And as you can see, right, once I click on that, it will tell me inside that experiment. Currently, I had only one run, but if there are multiple runs, there will be multiple runs shown with the different status and the compute target and the run type. So run type was automated ML and it was completed, right? So this was completed. Now I can go click here inside the run details, and then I will be able to see all the metrics. So if once your experiment is completed, you should be able to see the message as completed. And then because we had already checked the best model summary here, right? You see here, which is why, it is giving me the best model summary, that it has used max app scaler and light GBM. Okay, so this is the algorithm name which it has used, and it is giving me the hyperparameters. You can view the hyperparameters here, like some of the examples of hyperparameters are, for example, number of epochs or batch size or ReLU, learning rate, right? So it will give the hyperparameters that it has used here. As you can see, for the light GBM regression, it has a hyperparameter of min data in leaf as 20. Or for the max app scaler, there was no specific hyperparameter used. Okay, and then we had specified the metric as a normalized root mean square error. Then what are the other metrics for a linear regression, right? So we have explained variance. Explain variance means my model is able to 83% of the time explain the variance between the actual and the predicted, right? So which is good enough. It's highly accurate. More than 80% of the time, the variance is explained. Mean absolute error, percentage error, median error, normalized root mean square error, just root mean square error, Spearman correlation, R2 score. So for R2 score, I hope you know, the higher the R2 score, the better the model accuracy is. Most of the times, R2 score and root mean square error are good indications of your linear regression model accuracy. Okay, so these are some of the other metrics calculated apart from the one which we indicated. Okay, and you can also see here, models. So because we had clicked on model explanation as a part of the responsible AI tenet which we discussed, you can also view the explanation of that model. So it will tell you, like, the feature importance, like from all the data which we had. So in the data set, the bike rental data set, we had a lot of columns, right, which had wind speed and working days and all of those things. So so in amongst all those different columns, which are the ones which have a direct bearing on your output? So these are the 4 columns which have a maximum relevance to your rentals output column. All right, so this is the aggregate feature importance. You can see the model performance in different quantiles, the dataset explorer itself. Okay, so which will tell you, like, and you can select the you can select the individual data points as well, right? So here you can see. Okay, and then you can, in the aggregate feature importance, you can select whether you want a bar or a box chart. Okay, and you can also see the feature, like apart from the ones which are recorded here, you can also see the other features. So if I select day, it will show me that the data dependence plot for the day itself, like in the day range. Okay, the feature importance of day, as you can see, was not very much for the bike, for the bike rentals, the target column itself. Okay, so a lot of things you can see here: individual feature importance, aggregate feature importance, right? And you will be able to see which feature was impacting or influencing your final bike rentals, and that is why it chose the model, and that is why it came up with this particular metrics, RMSE and stuff like that. So once if you're already asked it for model explainability, it will be able to see all of these explanations once you click on model, right? So here again, in the details, so you will be able to see, yeah, explanations, and you'll be able to see the metrics, different metrics, right here. And if you have any test results, so we don't have any test results. Okay, and monitoring preview. Monitoring is if I want to monitor my model for data drift, I can do that. Okay, so what question was being asked, like how are you going to monitor for change in data and stuff? You can do that. So these three features are still not GA, generally available for your auto ML, but definitely data drift detection and stuff is available for your normal Azure machine learning pipelines. All right, so this is one of the automated ML, very brief overview what you can do. Similarly, you can do the same with designer, right? So I have already built classification designer model, right? And then whatever steps are, I mean, if your pipeline is running successfully, already run successfully, you will see all the steps marked as green there, like our SSIS packages, right? I mean, if all the different SSIS packages steps were executed successfully, you see green there. So it is same like that. And then how to use this sort of thing is, you have different what you saw in the automated ML, it is same for the designer as well, just that instead of clicking next and doing configuration on the portal here, you can do it on a designer. So you have a data set, right? You have see data sets here. So I can, whatever data sets I create, I will be able to drag them here. So like this, for example, and then I'll be able to view the columns here. Okay, so you can see the columns here, my data set columns. What I mean, are they imported correctly or not? So I'm able to drag. Then once the data set is decided, then if I want to have data normalization, okay, so like in my bike rental data set, or in my diabetes data set, I have different ranges of numbers, right? So I want to be able to normalize data. So in normalized data, what transformation method I'm using? Am I using logistic, or am I using min max, or I'm using TANH? Okay, so what are the transform normalization methods I'm using? Okay, then this is the split data which we saw, where we are splitting the data between training and validation. And then finally, which type of algorithm I'm using. So for a binary classification, I'm using a two-class logistic regression. So all these you can search from here. For example, let us check for split. Okay, then if I check for split, it will give me split data, split image directory, apply SQL transformation. So I'm using a split data transform. Then after a split data, and after deciding on the choice of the algorithm itself, then I will be training the model. So that 80% split will be trained. So in the split data, you can specify the split, right? Here it is 70-30. Okay, so fraction of rows. So 70% for the trained model, 30% for validation. And stratified split, I have put it as no. I don't want any stratified split. Okay, because I don't have any strata column here, right? That is more. So in the after after training the model, I will be scoring the model. For scoring, the other 30% split should be coming here, and there will be model evaluation, wherein same thing, right? I mean, it's the model metrics. So for a two class logistic regression, or for a binary classification, I will be able to use the evaluation metrics as the confusion matrix, right? Which is the mean, average, precision, and the recall, average recall, and stuff like that. So this is again, automated ML, but more in a designer form, where you can choose the different steps in a form of a pipeline. Okay, so these steps, and then you can persist them basically. So you can persist them, and then you can run this pipeline again and again for different data sources, or for different transformation steps. Okay, so this is another way of coding your automated ML. And same thing, you can publish the pipeline, and then you will be given endpoint of that published model where you can consume that in your applications. All right, let us look at pipelines itself, where I have certain custom pipelines which are built. Okay, so let me show you. um, yeah, let me show you a pipeline which we built. Right. So let me show you a pipeline for image detection which we built. So we have a VOC data set. Okay. Then we are training the model. Then after the model is trained, we are doing an inferencing. Okay. So inferencing, and finally we are checking the performance. So performance of that model. So this is a pipeline which we built. Now we have published the pipeline. Okay. So this is after you publish the pipeline, you will get an endpoint like this. See, test endpoint. Okay. So endpoint will get once you publish the pipeline, which means, you can also parameterize this pipeline. So which means my pipeline here right now, if I were to see the parameters, see it is accepting the parameters as the data set name, the data set, the source file test, the source file path from where you should be picking up the data set for retraining. So let's say, if I were to add more data and now I want to retrain my model, I will just pass in the name of the source data from which it should take the new data and start retraining. So this is my parameterized pipeline. So I can parameterize it, and I can run it with runtime parameters, different parameters, like how you call your functions with different parameters, right? So this is same way. Imagine that it is a persisted pipeline, and you can call it with different parameters. Parameters can be for, for the data set itself, the data set source path, the different hyper parameters you're going to use, and all of these things. Okay, so you can create a parameterized pipeline, publish it, and then invoke it sorry yeah, and you can invoke it from your application. So at runtime you can pass different parameters and invoke this pipeline. So it will run the pipeline, create different runs for different parameters. Okay, and you can see as here, right? For example, compute type, framework, script, which script to use, arguments, the Docker status enabled, epochs, batch size, model type, which model type, whether it is faster RCNN or YOLO, learning rate. These are all the train model parameters which I'm going to pass. Okay. So each step, as you can see, has different parameters. Train model has different parameters. VOC data set has the data file path as the parameter. Inference doesn't have any parameters. Okay, but the train model step has so many parameters, right? From epochs, batch size, model type, learning rate, Docker environment, and all of these things. Okay, so another way of productionalizing or building workloads for production is by using Azure Machine Learning pipelines, where you can build flows which you can then also do CI/CD for different environments, and also monitor for your data drift and retraining models and stuff like that. So we are at the top of the hour here. Any questions up till now? So someone told me that they have a question. They'll ask it at the end.
Yeah, hi. Yeah, this is Rakesh.
Yes, Rakesh, tell me.
Yeah, a quick question. Like, the manual way that I log into that, but is there any Python library someone has to code the whole process, like setting up the, let's say my project, I have my anomaly detection project. So one thing, and I want to set up my own product level, like for the CI part, I have on my libraries to use, and Azure also providing the ARM template. So is there any best way to do from the CI/CD, the pipeline scripting? Because I don't want to, as a end user, I can't expect to do manually. So any best way you did from your project side, so that it would be helpful for us here.
Yeah, okay. So, okay, the thing is, when for example, as a data, so I am a data scientist, right? I am not a person who's coding for the ML ops, right? So as a data scientist, I will normally, as I said, right, I will build these production pipelines or machine learning pipelines with parameterized pipelines, now the way to still, you know, sort of have auto CI/CD deployments and all, I will use the Azure ML CI/CD. Have you used that using, you know, I mean, so normally we are using Bitbucket as our source control, Bitbucket or Atlassian
Yeah.
Bitbucket as our source control, and then that will be where we will be persisting the various versions of our pipelines and also the triggers for those pipelines. So all those triggers using CI/CD and Azure DevOps and Atlassian Bitbucket are by Python scripting only. So I'm using the
Okay.
Azure DevOps and I'm using the Atlassian Bitbucket source control and creating the triggers using Python scripts only. So
So is
I'm
that
not using, yeah.
yeah,
Yes, go
is
ahead.
that you have built your custom Python scripts, or Azure already have that OM templates and other pipeline scripts in that you are used?
Okay, so the
Uh,
thing is, Azure has their own ARM templates, but because typically so let me show you a huge, a sample real machine learning pipeline. Okay, let us not talk of the small stuff which we code, which is AutoML or Designer. Okay, let
yeah,
me show
yeah.
you a real notebook, how it looks like. Okay, so let me go. This is yeah, correct. This is correct. No, sorry. Is it Dev Studio? US Studio. Okay, now let us look at object detection, right?
Because why I asked this question is,
Mhm.
when I was building the classification model for my bank transaction data, where I
Correct.
work for a bank, so it has to happen to me. I don't have the Azure ML Studio access. It's
Hmm.
very costly. So I have gone
Correct.
through the Databricks. I
Okay.
created
Yes,
Databricks, I
yes,
created Bob
Databricks.
storage, I integrated with the pipeline scripting. With the
Okay.
Azure DevOps, I just enable subscription, I create a workspace and variable
Hmm.
group.
Hmm.
That's where I trigger my pipeline. So that's why I took my pipeline. And what are the changes happen on that? I just commit from local git bash, then whole pipeline has to run and model will
Correct.
build. And I use some of the libraries like Azure Monitoring Drift Detector. So
Huh.
things will be
Correct.
explainable. Is there anything
Correct.
process you guys are followed? Because with the manual stuff, no one will allow in the organization. So some of the thing, the the
No, no,
bright level side is
absolutely,
there. Yeah.
absolutely, absolutely right. So if you say, I mean, for us, right, it is a combination of using again, as I said, Databricks, Azure Databricks, along with your Azure Machine Learning notebooks, Docker containers also, and then HyperDrive experiments as well. So you see HyperDrive experiments here. You
Yes, yes.
see pipelines created, pipeline steps created for each of those things. You have a model training which has like hundreds of other sub
Yeah, I got it.
steps.
I got
Okay.
it. I got it.
Yes.
Thank you.